Now we come to the concept of scientific notation. In science and maths, we end up with numbers that are really, really big and really, really small. And if we were to write them out in normal decimal form, they end up forming really, really, really long strings of digits, which make them really, really difficult to work with and to understand. So, for example, here I've got a big number. That's the thousands, millions, billions, trillions. Okay, so this is 3,802 billion. Yeah, 3,802 billion. A really big number. Now, if I want to change that into scientific notation, what I need to do is I need to make it into a number that has just one digit, then a decimal point, then everything else coming after it, to a power of 10. And I'll show you what I mean by that. Okay, if I want to rewrite this, I can rewrite it as 3.802 times 10 to the power of 12. So hopefully you can see the similarity between this number and this number. We've got the 3, the 8, the 0 and the 2 here. Then we've got rid of all of these extra zeros. These numbers mean exactly the same thing. This is it written out in full, and this here uses a bit of shorthand. 10 to the power of 12 is the same as a 1 with 12 zeros after it. It's 10 times 10 times 10 times 10, 12 times. We've already covered indices. So if I were to multiply 3.802 by a 1 with 12 zeros after it, I would get this. Anytime there's a 10 with a power on it multiplied by a number, you can change it back into a decimal by moving the decimal place the number of times that the 10 is to a power. I'll show you what that looks like. So if I was going to change this back into a decimal number, it'd be 3.802, and I'd move the decimal place across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times to put it over here. Now you can see I've jumped over these 3 digits, and every other jump would become 0. And you can see I'm back where I started again. So to change that, what I did was I actually counted the other way. I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to put the decimal place there and work out what my power of 10 was going to be. I'll do another one. We'll show you what it's like. 27000. This is a much smaller number, but if I want to write it as scientific notation, it's really quite simple. I'm going to have to make a power 1, 2, 3, 4. 10 to the power of 4 is going to be involved. And at the front I'll have 2.7 and 10 to the power of 4. Okay? That is equal to that. This is equal to this, which is again equal back to that again. Here's another example. 35032900000. Okay, again, I'm going to put a number out the front, which is going to have the decimal place after the first digit, and then I'm going to have times 10 to the power of something. And I do this to work it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3.5039 times 10 to the power of 10. Because that's how many jumps I did. Okay? So this is the most basic way of changing from one type to the other. If I put up another one here, let's say this is 2.8 times 10 to the power of 6. I've got that in scientific notation. If I want to change that to decimal form, then I would move the decimal place over 6 times. Put the 2 and the 8 there, and the decimal place is going to go over once, 2, 3, 4, 5, 6. And where I've got a spare space here, I need to put a 0 in. Okay, so 2.8 times 10 to the power of 6 is 2,800,000. Okay, so that's scientific notation when we're dealing with very large numbers. In the next video, I'll do scientific notation when we're dealing with very small numbers.